Hello friends, I welcome you in lecture number 11 on Poisson distribution. In this lecture, we are going to discuss this question on Poisson distribution which was asked in GTU Winter 2021 exam. A book contains 100 misprints distributed randomly throughout its 100 pages. What is the probability that a page observed at random contains at least 2 misprints? So first we have to identify that what is the random variable for this question, and we can see here it is given that some book contains 100 misprints distributed randomly throughout its 100 pages. There are 100 pages in the book and there are 100 misprints distributed randomly throughout these 100 pages. So we are asked to find the probability that if we select randomly one page out of these 100 pages, then what is the probability that that randomly selected page contains at least 2 misprints. So first we have to decide the random variable or which random variable we have to consider. So here we will consider random variable x as here the concern is about the misprints in a page. So we can consider the number of misprints in a page as the random variable under consideration. Let x be the random variable which is the number of misprints in a page of the book or number of misprints in a page. Then we can say that the possible values of this random variable are 0, 1, 2, etc. So this is the discrete random variable, and we know that whenever we have the number of events during some interval, then we say that that random variable is a Poisson random variable. So this is the problem of Poisson distribution. The variable capital X, which is the number of misprints in a page, is a Poisson random variable. So if we have Poisson random variable, then we have to find out the average number of misprints per page. Here X is a Poisson random variable, and whenever we have Poisson random variable, to write down the probability mass function of that random variable, we require the lambda, that is mean of Poisson distribution. So what is the mean of Poisson distribution? If x is the number of misprints in a page, then average number of misprints in a page will be mean of this Poisson random variable. So that we can decide from this. It is given that there are 100 misprints throughout 100 pages. That is, if we have 100 pages, suppose we write pages here, and here we write number of misprints. So if we have 100 pages, then it is given that there are 100 misprints. Therefore, if we have one page, then what will be the number of misprints? So that is going to be 1 into 100 divided by 100, that is 1. 100 will cancel out. So this is our average number of misprints in a page. So therefore we will consider lambda equal to average number of misprints per page is equal to 1. Now once we have value of lambda, we can write down the probability mass function of Poisson random variable x. The probability mass function of x is given by probability that capital X equal to x is equal to e raised to minus lambda raised to x divided by x factorial. X is starting from 0, 1, 2 and so on. Therefore, probability that capital X takes the value small x is equal to lambda is 1. So we have e raised to minus 1 raised to x divided by x factorial, or we can simply write this as e raised to minus 1 divided by x factorial, because 1 raised to x is 1, and therefore probability that capital X equal to x is equal to e to the power minus 1 divided by x factorial, x equal to 0, 1, 2 and so on. This capital X equal to x means x number of misprints per page. The probability that there are x misprints per page is given by e raised to minus 1 divided by x factorial. And here we are asked to find the probability that if we select a page randomly, then what is the probability that that page contains at least 2 misprints, that is number of misprints are at least 2, that is we have to find out the probability that capital X is greater than or equal to 2. So that is that we are going to find now. So required probability is equal to probability that the number of misprints on a page are at least 2, and this I can write as in terms of random variable capital X. This is probability that capital X is greater than or equal to 2, and this we can rewrite as 1 minus probability of complementary event of capital X greater than or equal to 2, which is capital X is less than 2, and capital X less than 2 means possible values are capital X equal to 0 and capital X equal to 1, and these two we can decide using this formula of probability mass function. If I take capital X equal to 0, I will have e raised to minus 1 over 0 factorial. So let me write here e raised to minus 1 divided by 0 factorial, and here e raised to minus 1 divided by 1 factorial for x equal to 1, e raised to minus 1 divided by 1 factorial. So this becomes 1 minus, we can see 0 factorial is 1, 1 factorial is also 1, so this is 1 minus 2 times e raised to minus 1, and if I use my scientific calculator, I have to press the button shift e minus 1, that will give me e raised to minus 1 into 2, that is 0.736 up to 3 decimal places, and this is equal to 0.264. Therefore, the required probability that a randomly selected page contains at least 2 misprints is equal to 0.264. So in this way we can easily answer this type of questions. The main thing we have to understand is that given random variable is which random variable. Here we are given the number of misprints in a page, therefore this random variable becomes Poisson random variable. Whenever we have number of events per unit time or per unit mass, then that random variable is going to a Poisson random variable. So here capital X is a Poisson random variable, and we require mean of Poisson random variable that we can find using given information. It is given that there are 100 misprints in 100 pages, therefore we can decide the average number of misprints per page, and it becomes 1, and we must remember the formula for PMF of Poisson distribution, and once we find out value of lambda, we can easily find out the required probabilities. So okay, fine, this is all about this session. I hope you like it. Thanks for watching.